Hello everyone, welcome to another video. Here we'll be discussing more numericals on quantum mechanics. Okay, so these are Zettili numericals. So we will be continuing that uh, video. I gave you some homework. I hope you have done it. Okay. So next question. Right now. Here we have to solve the Dirac delta functions. Okay. The first equation is 0 to pi sine 3x cos square 4x delta x minus pi by 2. Okay, dx. Is it alright? Sine 3x cos square 4x delta x minus pi by 2 dx. Okay, so how to do it? See, first of all, which formula you will use here? I'll just write down the formulas again for Dirac delta function. Okay, okay, so the formulas are a to b dx fx delta x minus c is equal to n. Suppose this c is between a and b, so this would be f of c. Okay, and your c will be between a and b and 0 otherwise. Okay, is it alright? Okay, this is the first formula. And second formula, a to b dx fx ln x minus c is equal to minus 1 to the power n fn c. Okay, a c b 0 otherwise. Is it alright? Okay, minus 1 to the power n fn c, a to c, a to b, this is 0 otherwise. Okay, next formula is del ax is equal to 1 by a del x. Okay, iv is del f of x is equal to summation j delta x minus xj divided by f dash xj. Okay, is it all right? See, where here xj are zeros of f of x. Okay, where f dash x is not equal to 0. Hmm. So these are the formulas that will be used in this next questions. Okay, so let's first try this question. First question is okay, we try this question first. 0 to pi sine 3x cos square 4x delta x minus pi by 2. Okay, please try this question. I'm giving you 2 minutes. Okay, so how to solve this question? See, this pi by 2 here is between 0 to pi. So I can put it directly in place of x, right? I'll write it as sine 3 pi by 2 cos square 4 pi by 2. Okay? That will be sine 3 pi by 2 to cos square 2 pi. Cos 2 pi is cos 0. Sine 3 pi by 2 is minus 1. So the answer will be minus 1. Okay? Next question. Question number 2. Integration minus 2 to 2 e to the power 7x plus 2 delta 5x dx. Okay? Try this. Try this question. Try this question. You have 2 minutes. Try. You have 2 minutes. Okay, how did you solve the question? Okay, see here I can use the formula del of ax actually is equal to 1 by a del of x, right? So this I can write 1 by 5 in del of x. So 1 by 5 put it. So 1 by 5 goes out. Minus 2 to 2 e to the power 7x plus 2 del x dx. So now what? See, this is x minus 0, isn't it? So 0 is between minus 2 to 2. So I can put it directly here. So 1 by 5 e to the power 7 into 0 plus 2. 1 by 5 e to the power 2. Okay. Next question. Minus 2 pi to 2 pi sine theta by 2 double dash theta plus pi d theta. Okay. Okay. Sine theta by 2 delta double dash theta plus pi d theta. Hmm. So how to solve this one here? So what is the formula for this? Tell me. Tell me. So here I will be using minus 1 to the power n dn by d theta n. Okay, whatever there is inside f theta. Okay, at theta is equal to what? This one c. So minus 1, how many times did we take it, we have taken derivative? The del dash, double dash, that means 2. Minus 1 to the power 2. D square by d theta square. Sine theta by 2 at theta is equal to what? Minus pi. Okay. So this is d square by d theta square. Um, Sine theta by 2 is, okay, sine theta, sorry, sine theta by 2. Here is minus pi. So I will take the first derivative is cos theta by 2. 1 by 2, then d by d theta is equal to 1 by 2 minus 1 by 4 sine theta by 2. And then I have to put, theta is equal to minus pi. So sine minus pi is minus sine pi, that is sine pi is 0. So this is, okay, sine pi is by 2 minus sine pi by 2. So 1 by 4 into 1. So minus 1 by 4 sine minus pi by 2. This is plus 1 by 4 sine pi by 2. 1 by 4. Okay. Is it alright? Next question. 0 to 2 pi cos square theta square theta delta theta minus pi will divided by 4 d theta. Okay. Cos square theta del theta minus pi whole divided by 4 d theta. What to do it? See here, when it was like del 4x, we were writing it as 1 by 4 del x. So when it is del x by 4, can I write it as 1 by 1 by 4? Isn't it? Because 1 by 4 is multiplied inside del x. So let's write it. So this I can write, this one I can write 1 equal to 1 by 4 del theta minus pi. Okay. So 4 del theta minus pi. Right. So 4 goes out, 0 to 2 pi cos square theta delta theta minus pi d theta. Okay. So I will put this pi here. So 4 0 to pi. Okay, no. So 4 cos square pi d theta. Sorry, again. Cos pi is minus 1. So minus 1 square is 1. So 4. Answer is 4. Okay. Answer is 4. I hope you understood these questions. These are from Dirac Delta. Okay. Is it alright? It's alright. Another question. Easy question now. 0 to 5. 3x square plus 2 delta x minus 1 dx. Do it. Okay, done. This is easy. X minus 1 is equal to 0. X is equal to 1. So just have to put it 3 into 1 is 5. Okay, right, next question. This is our exercise 2.47 of Zettili. If the position and momentum operators, the position and momentum operators are are denoted by R and P respectively to, so that so that P dagger R to the power n P is equal to minus 1 to the power n R to the power n. Okay, and P dagger P and P is equal to minus 1 to the power n P dagger n, where P is the parity operator, where P is the parity operator and n is an integer, and n is an integer. Okay, if the position momentum operators are denoted by R and P respectively, so that P is this and P is this, where P is the parity operator, n is an integer. Okay, try this question. Try this question. Hmm. Okay, so see, how will you solve it? Here we will use the fact that P is an what? Unitary operator, right? P is an unitary operator. That is what? P dagger P is equal to I. I is a unit operator. So we can also use the fact that R and P, R and P what? Have negative parity, isn't it? R and P have negative parity. Okay? R and P have negative parity. That is, you can say uh, is equal to minus R. Okay? Yeah? So this is a negative parity. And um, you can also write it like this. Sorry, this is there is no vector here. Sorry. Is equal to what? Minus P. Okay? Because it has negative parity. That's why. So I can also write C very carefully. R to the power n. Okay, we have to prove this R to the power n, because see what we have to prove here. This one, if R to the power n is there, minus 1 to the power n, R to the power n. Okay, so this is, I can write this as P cap. Okay, and I can Like, tell me whether I can write like this. I'll be writing this. Why I wrote like, I'll be writing this n times. Okay, this is what n times inside. So that will give me out of the power n, isn't it? Isn't it? Okay. Hmm. So if you see I can write I as what? I can write I as this. Okay. So I will put in place of I that p dagger p. So p dagger p I can put right. Hmm. In p dagger p. Okay. So it will go on and on. If you see again now, you see what is this? What is this? If you extract here, sorry, I can exchange this. Okay, I can exchange this. So this will become. You'll realize now why I'm doing this. So this is n times, no? So if you see this is what I have written here minus r, isn't it? This is minus r. So I can write it as minus r. Okay, and this is repeated how many times? N times. So minus r to the power n. Okay, so I can write this also as minus 1 to the power n because this is minus and r to the power n. Is it clear? It's a bit like logic wise, we have to solve the logic and with a bit of deduction. Okay, we have to solve it. Is it all right? I hope you understood this. Okay. Okay. The next one is a bit tricky one. Try this one. This is exercise 2.15. Okay. So prove the following two relations. Prove the following two relations. Okay. First one is a cap e to the power b cap is equal to e a cap plus b cap e a cap b cap by 2. Okay. So e a cap b cap e to the power minus e a cap is equal to b cap plus a cap b cap. Okay. Plus half 1 by 2 factorial a cap a cap b cap. Okay. Plus 1 by 3 factorial a cap b cap a cap b cap. Okay. So try this question. You have 2 minutes. Try this question. Did you try? Did you try to prove this? Okay, see. Okay, which we have to use the expansion formula of E, that is e to the power a cap is equal to summation n a to the power n by n factorial. Okay, it's equal to 1 plus a cap plus a cap square by 2 factorial. Okay, plus dot dot dot. So we have to use this here. Okay, now e a cap e to the power b cap is equal to summation n a to the power n by n factorial. Okay, summation n b to the power m by m factorial. Okay, this is alright. So e to the power a cap into e to the power b cap is equal to, we can write it as 1 plus a cap plus a cap square by 2 factorial dot dot dot. Okay, 1 plus b cap plus b cap square plus 2 factorial dot dot dot. Okay, so we will be try to multiply them. So 1 plus a cap we will multiply with this plus a cap square by 2 factorial plus dot 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 plus b cap will start now, and plus b cap square by 2 factorial plus dot 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 plus a cap b cap plus a cap b cap square by 2 factorial. Okay, plus dot 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 a square b cap by 2 factorial plus hmm, a square b square divided by 2 factorial into 2 factorial, a square into b square by 2 factorial into 2 factorial. Okay, I'm just multiplying them. You can see I can multiply them. So it will go on, and from there we can prove it that this will be a cap plus b cap. Okay, if you see it, plus e a cap b cap by 2. Okay, and this can be proved from here. Okay, yeah. If we do the same kind of algebra in this second question also, in option beta, like part B, this is like this: b minus a cap is equal to 1 plus, again in place of this I will put its expansion, a cap square by 2 factorial dot dot dot. Then your b cap will be here, and now the expansion of this one, that is 1 minus a cap plus a cap square by 2 dot dot dot, and a cap b cap minus a cap is equal to b cap. Now I'll multiply again, same thing, plus if you see this, you will be able to solve this b cap a cap. Okay, because see ab and here minus b. Okay, minus b, so that will give me, this is a. Okay, this is plus ab, this is minus b, so this is ap plus b, ab minus b. Exactly same thing will go on here, and you will get something like this. Okay, I hope you can solve it. I'm not going to solve it in all. For all this, you should be able to do this. And b plus, this is your commutator, right? A comma b, hmm, plus 1 by 2 factorial. Okay, a comma a comma b plus, is it all right? So this is what is it is. Okay, is it all right? Okay, so with this, I think we have completed most of the type of questions from this chapter, which was your mathematical tools of quantum mechanics. We have kind of solved it. You try to solve all the questions of Zettili, okay, in this chapter, mathematical tools of quantum mechanics. So I hope everything is clear. So in the next session, we'll be moving to the next chapter, which is your postulates of quantum mechanics. That will be your chapter 3 of the Zettili book, the postulates of postulates of quantum mechanics. I will be moving next to that. Okay. Till then, you try to solve all the questions from the second exercise of the Zettili book. Okay. Okay. Thank you for watching. Thank you very much.